Hello and welcome to Mr. Davis's Algebra 2 class. Today we're going to be taking notes on factoring quadratics, and this is lesson 4.4 in your books. If you want to follow along in your book, this is starting on page 216. Okay. So factoring quadratics. This is usually everybody's favorite is factoring. All right. In factoring, we're turning a problem into a multiplication problem. So from here, we have standard form, and we're turning it into multiplication problem. See how there's two parentheses here? That means multiplication. So we actually turn it into like a FOIL problem, right? So it's a multiplication problem. That is our goal for each one of these, is turn it into a multiplication problem. Now, today we're just going to be learning how to do this, but we're not just factoring to factor. There's actually reasons behind it, and you'll see that down the road in our lessons. All right. So first off, we're going to factor a problem of x squared plus bx plus c. Now notice there's no a term, which means a is equal to 1, so it's always 1x squared. Okay. These are going to be the easiest to factor. All right. And what we need to do is we need to find two numbers that multiply to get c and add to get b. So what we're looking for is the multiply part is factors of 16. The add part is the sum of the factors. So if we're looking at 16, right, we want two numbers that multiply to get 16. So let's see, the easiest one is probably 1 and 16. Right, 1 times 16 is 16. But then the sum of factors is when we add them. When we add them, we get 17. We don't need 17. What we need is 10. So we can try it again. How about 4 and 4? 4 times 4 is 16. 4 plus 4 is 8. That doesn't work either. Now, probably by now, most of you guys have said, hey, what about 2 and 8? 2 times 8 is 16. 2 plus 8 is 10, right? We have 10 and 10. So what we can do now is this becomes a multiplication problem. So for these ones where a is equal to 1, we're going to split the x's here. Because we have x squared, right? So we're going to split, so 1x, 2x is x squared. And then I'm just going to take my two factors and plug them in, right? So that's a positive 2, positive 8. It does not matter which one you put first. If you put 8 first and 2 second, same exact answer. Does not matter. So this is the easiest type. Okay. So let's practice. This is problem 1, part C. Okay. So here we have negative x squared plus 13x minus 12. Now, you might see here right away, you might say, hey, a here is a negative 1. You said it had to be 1. Let's change this a little bit to make it a positive 1. So I'm going to take that negative sign and put it outside. All right. So I'm going to take that negative sign and put it outside, which flips the signs of the other pieces in here. Now I need two numbers that multiply to get 12, but add to get negative 13. All right. So I'm going to make my, let's see, factors sum. Well, let's start with the easiest one, 1 times 12. 1 times 12 is 12. 1 plus 12 is 13. All right, you might think you have it, but you do not, because this right here is a positive 13. What we need is a negative 13. So how can we change that so it's negative? Well, hopefully you can notice that negative 1 times a negative 12 is still a positive 12, but negative 1 plus negative 12 is negative 13. So we're going to split our x's. We have a negative 1, negative 12, so that's going to be negative 1, negative 12. And it's factored. Again, it doesn't matter if the negative 1 goes first or the negative 12 goes first. It's your choice. So that's problem 1, part C. Problem 1, part B. We have x squared plus 14x minus 72. So we need to make our factor sum, right? two numbers that multiply to get negative 72. Right. So easy one is 72 and 1, but I don't think that's going to work out. Let's try maybe 3 and well, we need to get a negative 72, so I guess that's going to have to be 3 and negative 24. So 3 times negative 24 is negative 72. 3 plus negative 24 is negative 21. Well, it's not the right number, and also this one here is negative, while this one here is positive. So I think we probably need to put that minus sign on the smaller number. So let's try to get in with two different numbers and put the negative sign with the smaller number. So I'm going to say negative. How about, does 4 go into this? I think it does. Let's say negative 4, and would this be 18, I think? Negative 4 and 18. So negative 4 times 18 is negative 72. Negative 4 plus 18 is 14. There we go. I think we got it. So, again, we split the x's. Put in a negative 4 and a positive 18. Again, it doesn't matter which one goes first, but you need to make sure the negative sign always sticks with the 4. The positive sign sticks with the 18. So if you switch them, you can't put the negative sign with the 18. All right. Now, just to show you guys why it ends up like this, is let's use FOIL to undo this multiplication here. All right. So we have first x times x. Well, that's x squared. Outer x times 18. So that's plus 18x. Inner is negative 4x. And last is negative 72. When I combine my like terms, I get x squared plus 14x minus 72, which is what we started with. So really we haven't, we've just changed the way the problem looks. We haven't changed its mathematical meaning. All right, this is the second easiest type of factoring. It's the GCF, greatest common factor. So sometimes it's going to be easier to factor out the greatest common factor instead. So like on this one here, we have these two terms here, and they have some things in common. One thing they have in common is a 3. Right? 3 goes into 6, 3 goes into 9. And another thing that they have in common is an x. So 3x is what they have in common. If I pull out a 3x, I'm left with 2x here. Right? 3x times 2x is 6x squared. Plus 3, because 3 times 3x is 9x. Right? And that is, in fact, factored. Right? It looks different because there's only one set of parentheses, but still a multiplication problem, right? That's multiplication right there. Still multiplication problem. Still factored. Right? So that's pretty easy. Sometimes GCF will, in fact, just factor it for you like this. Sometimes it'll just make it, change it so you can factor it. An example of that one is, oops, hold on. There we go. Like this one here. Right. So this one right here, we have 4x squared. So A is equal to 4. Now, we said that we can do factor sum if A is equal to 1. So what I'm going to do is I'm going to do GCF to turn that to 1. So I'm going to take a 4 and I'll factor the 4 out, leaving me with x squared. So this is the important part here. So if I factor 4 out, that's going to be 5x's minus, let's see, that would be 14. All right. Now it's in a form that we can factor. Right. Now we need factor sum. We need factor 14, add to get a positive 5. Well, let's try, let's see, you can do 14 and 1, but how about a 7 and a 2, right? So one of them has to be negative, but we know the middle term is positive, so that means the smaller number has to be negative. Negative 2 times 7 is negative 14. Negative 2 plus 7 is 5. There we go. Got it. And then now we can split apart the x, put in a negative 2 and a positive 7. and it's factored, right? So that's a way that GCF can help. Now in this one, I didn't only do GCF. I did first step GCF, second step factor sum. Sometimes GCF just makes it easier to factor a different way. A good piece of advice is always look for GCF first, because no matter what, it should simplify the problem for you. So if you can use GCF, use it first and then try solving it with these other methods. All right, now we're getting to one that's kind of difficult. Now this is problem 3, part A. Now what we just learned was the GCF, right? So we might think, hey, let's factor out of 2, and then A will be equal to 1, and then we can factor it from there. Okay. So if we try that though, we have this 11 term right here, which 2 doesn't go into it. So 2 is not the greatest common factor, so we can't use that. So when we can't use GCF, what we need to use is something that we'll call AC. Okay. AC. It's called AC because of what we're going to do is we're going to take the A term times the C term. So AC will be 2 times 12, which is 24. Okay. So AC is 24. This we're going to use, it's very similar to factor sum, except for instead of using 12, we're using 24. Now for sum, it needs to add to 11. So we need to come up with 2 numbers that multiply to get 24 and add to get 11. So let's start 1, 24. 1 times 24 is 24. 1 plus 24 is 25. We need 11. We can do 2 and 12, but let's skip ahead to 3 and 8. 3 times 8 is 24. 3 plus 8 is 11. There we go. We got it. Now, doing it AC isn't as simple as now plugging them back in like it was when we were just doing factor sum. With AC, we need to rewrite this equation. So I'm going to write 2x squared, and instead of 11x squared, I'm going to write plus 3x's plus 8x's plus 12. Now, do we agree that this is the same? All right. I just dropped down the 2 and the 12, and then the 11 I split into 3x plus 8x. Now 3x plus 8x is 11x. So it's okay to split it apart, and what I'm going to do is factor by grouping. Okay? Factor by grouping. Now, I'm going to use a different color to accentuate this point, but what I'm going to be doing is I'm going to be saying, hey, I want to group those terms there. And now I want to use GCF on those specific groups. So if I look at this first part, what do those 2 have in common? They only have an x in common. So I have 2x plus 3. Looking at the second part, what do those 2 numbers have in common? I think they have a 4 in common. Now, what you might have noticed, what we have here is 2x plus 3 and 2x plus 3. Those are exactly the same. And that's what this AC does, is it makes those 2 parts exactly the same. So what I'm going to do now is I'm going to take those 2 pieces and I'm going to put them into the same parenthesis. Now we said we wanted to make it a multiplication problem. What's going to go in this first part is x plus 4. Now it is factored doing it with AC. All right. So like I said, it's a little bit more difficult. All right. But once you get the hang of it, it's not so bad. All right. Let's try this one. All right. Let's see. First thing that we should think about is GCF. Can we do this with GCF? And that 3 messes it up, doesn't it? So we can't use a GCF, but we can use AC. So AC. A is 4, C is negative 3, AC is negative 12. My sum needs to be negative 4. So I need 2 numbers that multiply to get negative 12, add to get negative 4. So we could try out 1, negative 12. Now it'll give us negative 11, so that doesn't work. How about 2 and negative 6? 2 times negative 6, negative 12. 2 plus negative 6, negative 4. I think that's it right there. Remember, now the next step is to rewrite this. 4x squared minus, or I guess plus 2x minus 6x minus 3. Then we need to group and figure out our GCF. So I'm going to group. There we go. What's in common in the first part is 2x. Just going to leave us with 2x plus 1. And this second part here is, what do they have in common? Well, it looks like they have a negative 3 in common. Okay. One bit of advice is every time we're grouping and there's a negative sign on that term right there, you want to group that inside. All right? You don't want to leave it outside. You want to group it inside. All right. We have negative 3 is 2x plus 1. Did our groupings end up being the same? They did, 2x plus 1. So now I can rewrite this as 2x minus 3, 2x plus 1. And that is our factored problem. Multiplication problem. I think we got it. Now there's some special cases of factoring. All right. This one's a perfect square trinomial. Now, if we do this one with factor sum, right, a is 1, so we can do this. We need to factor 25 and add to get 10. Well, if we use 5 and 5, we get 10, which makes it x plus 5x plus 5, which even reduces further to x plus 5 squared. So since we have x plus 5 squared, that's the difference here. These perfect square ones are going to be the pieces that reduce to that, which means that they're going to have the same two numbers, right? A 5 and a 5. Now this perfect square trinomial is pretty easy to do when the a value is 1 over here. But what about when it's not 1? Right? So we're going to have a checklist. All right, this is a perfect square checklist. You're probably going to want to put this in your notes just so you can look at it when you get stumped. Now, it says, what is this in factored form? Right. What is that in factored form? Well, the a value is 4. Now, we could probably, factor out of 4 and then do, factoring. But if we have the perfect square checklist, we can do it quicker. So is the first term a perfect square? And what I mean by that is, right, this is 4x squared. Can it be written as something squared? Well, we know the x part is, perfect square. What we need to look at is the number part. Can that 4 be written as something squared? And I think we can realize that it's supposed to be 2 squared. Oh, let me get back to, there we go. Sorry. All right, so 2x squared. So we have 2x times 2x would be 4x squared. So that's what we're looking at when I say is the first term a perfect square. Is the last term a perfect square? Well, 36. Well, that's just 6 squared. So yes and yes, right? So we have 2 checks. All right, check on the first one, check on the second one. The last one is the middle term twice the product. And when I say twice the product, I'm talking about what we found here and here. So what I want to know is it twice? So that's 2 times 2x times 6. So 2 times 2x times 6, well that's 24x. All right, and we want to say, hey, is that middle term the same? Right. And then look at the middle term, 24x, 24x. So it passes the perfect square checklist. So it's got 3 checks, it means it's a perfect square. Now we just need to write it in perfect square form. Well, remember, perfect squares look like that. The first term is what we found up here on the first check mark, so 2x. The second term is what we found on the second check mark. Then we just need to look up here at this middle term and say, hey, is this middle term positive or negative? It's a negative. And then this is our perfect square. So that's the perfect square checklist. Another special case is difference of two squares. They look like a squared minus b squared is equal to, and then parentheses a plus b, parentheses a minus b. Right, so that's difference of two squares. These ones are a little bit easier to recognize than a perfect trinomial because most time, it's just going to be two terms with a minus sign in between. So let's look at what one looks like. So right here we have 25x squared minus 49. Right, two terms. Minus sign in the middle makes us think, hey, this is probably a difference of squares. So just like the last checklist for perfect squares, this one kind of has a checklist too. Right? First off, we want to say, hey, is the first part, the first term, a perfect square? Well, can we write that as something squared? Well, that's x squared. That's the easy part. But we want to know, hey, can 25 be written as something squared? And it's 5 squared. So it is a perfect square. What about that second term? Is that second term a perfect square? Well, I think it is. It's 7 squared. So since we have two squares with a minus sign between, it's a difference of squares, which means I'm going to write it as a plus b, a minus b. So it's going to be 5x plus 7, 5x minus 7. And that's the factored form. And again, it doesn't matter if the minus sign comes first or second. It's your choice. But there needs to be one of each in there. All right. So that's the special case of difference of squares. Your homework is on page 221. It's 15 through 57 odd, 59 through 90 all. Right. Have fun, and thank you for coming.